I'm Rayesh Uppal, founder of IDST. We bring you sharp insights and foresight on emerging tech, defense, and security. Let's dive in.
When we think of the deep ocean, we often imagine a mysterious, unexplored world, but beneath those dark waters lies something even more important for our future. Resources that could reshape global industries. As reserves of critical minerals on land become harder to find and demand keeps rising, attention is turning to the ocean floor. And the key to unlocking this new frontier: deep sea mapping. This isn't just about drawing maps, it's about creating incredibly detailed, high-resolution images of the seafloor that can tell us where valuable minerals are hiding, how the terrain is shaped, and even what environmental risks we need to look out for. Without it, mining operations would be like searching in the dark, risky and inefficient. But with it, nations and companies can plan safer, smarter, and more sustainable ways of tapping into ocean resources. And make no mistake, this has become a global race. Countries like China, the United States, Norway, and several in Europe are investing heavily in underwater exploration. Why? Because whoever controls access to rare earth elements and critical metals also controls the future of advanced technologies, from batteries and renewable energy to fighter jets and satellites. It's not just economics, it's national security. So how do we actually map the ocean floor? It's done with a mix of cutting-edge technologies. Multi-beam echo sounders shoot sound waves that bounce off the seafloor and return, creating detailed 3D models of underwater mountains, ridges, and plains. Synthetic aperture sonar takes it further, delivering ultra-high resolution images that reveal even subtle geological features, the kind that might signal the presence of valuable mineral deposits. Then there are sub-bottom profilers, which penetrate beneath the seabed to show hidden layers of rock and sediment, almost like taking an X-ray of the Earth's crust. And to top it off, environmental sensors measure water temperature, chemistry, and salinity, so scientists can better understand the impact of any human activity. But the real stars of this effort are autonomous underwater vehicles, or AUVs. These robotic submarines are engineered to survive crushing pressures, freezing temperatures, and complete darkness. Equipped with sonars, cameras, lasers, and advanced navigation systems, they can dive thousands of meters, travel hundreds of kilometers, and operate for weeks at a time without human intervention. Companies like Kongsberg with their HUGIN series, Boeing's Voyager, and Saab's Sabertooth are building machines that not only map the ocean in stunning detail but also adapt in real time, making decisions on the fly using onboard AI. It's like having explorers that never tire, never need air, and can go places humans simply can't. The military is watching closely too. In fact, the US Navy has already been testing systems like HUGIN for deep water operations, recognizing that whoever masters the deep sea will hold a strategic advantage. These maps don't just help with mining, they could also influence naval strategies, undersea surveillance, and defense planning. But it's not all about extraction and power. Deep sea mapping is also about protection. By carefully mapping ecosystems, hydrothermal vents, and sensitive coral regions, scientists and regulators can guide mining operations to avoid fragile habitats. This is crucial because if deep-sea mining is going to happen, and it seems inevitable, it must be done responsibly, with sustainability at its core. In the end, deep-sea mapping is the foundation for everything. It enables the discovery of resources, guides safe operations, supports environmental stewardship, and shapes global strategy. As competition for critical minerals heats up, the nations and companies that master this technology will not only gain access to valuable resources but also define the rules of this new frontier. The oceans, once seen as a barrier, are becoming the next great resource hub. And the future of exploration, industry, and even security may very well depend on how well we can map the world beneath the waves.